You know, up to now, you have been reading weather reports for your pre-flight planning purposes, sort of like a book without pictures. So, guess what? Now you get the pictures. Well, a chart at any rate. But if you're like me, a picture or a chart of the weather is worth more than 1,000 words when it's compared to, say, an encoded weather report like a METAR or TAF. Well, with a picture or a chart, you'll be able to visualize weather patterns and see them a whole lot better because you can see the whole enchilada, so to speak. So being able to see a general overview of weather systems is often called understanding the synoptic situation. It's a picture of the weather in your mind. What it allows you to do is better understand what's causing weather at a specific location or going to cause weather at a specific location. And it allows you to get an idea of the movement of weather systems and fronts. Now, maybe this isn't as good as the talkies, but it isn't half bad. So you can see these pictures of the weather like this. This is a surface weather map at a flight service station if there's one nearby, or you can get it on the internet, or you can get a simplified version of the weather pictures like this on Duet. So let's take a look at them. Now, the first chart we're going to talk about is the surface analysis chart, or as it's better known sometimes by some people, the surface weather map. And as the name implies, it gives you information they get from existing or observed conditions at the surface, and it covers the contiguous 48 states. Those are the ones that are touching each other, folks, and it's issued every 3 hours. Now, this chart gives you the weather that the observers saw when they opened their windows and looked outside. In other words, it's an actual observation. And the time and date are shown down here, and they tell you when all this information was compiled and sent out. So it's a good idea to remember that this computer-generated chart could be several hours old and the weather may have changed since it was reported. So be sure to check that time and date when you're using the chart. Now, with that out of the way, let's take a look at what we can find out from this chart. Now, what this chart shows you especially well is pressure patterns, and we can start with isobars. Now, as you recall from the printed weather reports, one of the many conditions that ground stations report is the local pressure reference to sea level. Now, if you draw a line between stations that report the same pressure, you get a line of equal pressure, or an isobar. And that's what we have here in these charts, are isobars. Now, the gradient between the isobars, or how close they are together, shows how rapidly the pressure is changing from one point to another over an area here. And that pressure gradient tells you the wind strength. The closer the isobars are to each other, the more rapidly the pressure is changing and the stronger the wind. So by looking at this chart, if you want to avoid areas of strong wind, you can look at it and avoid areas where the isobars are very close together. So as a result, you can see pressure patterns here, and also you'll find areas of high and low pressure. And cleverly enough, the weather folks mark the high pressures with, are you ready for this? They mark them with an H. So here's an H up here, and the low pressures with an L like here, like so. And then right next to the pressure areas, they'll show you what the pressure is in millibars. Right here you can read that. It's about 1,008 millibars right there. Now, as you know, the surface winds spiral clockwise and outwards from high pressure areas and counterclockwise and inwards to low pressure areas. So you can get an idea of what's going on in the way of pressure patterns and winds just simply by studying the location of high and low pressure areas and the isobars. Plus, you can take a look at the station, and at each station you have a wind arrow like this, and it has feathers on it, and the wind direction is shown by the direction of the arrow, and the number of the feathers tells you the wind strength. If there are long feathers, they're 10 knots, half feathers, if they had them, would be 5 knots. Here, this wind is from the northwest at 20 knots. So all of this information we just talked about, the locations of the high and low pressure areas and the isobars and the wind arrows, all will give you a good feel for the direction and strength of the winds. Now, let's take a look at fronts. Fronts are shown on the chart just the way we talked about earlier. Cold fronts are shown with icicles. Warm fronts are shown with those half-sun symbols. And sometimes they're color-coded. You might see blue for a cold front, red for a warm front, or maybe purple for an occluded front. And as before, these icicles and half-suns all tell you the direction the front is moving. Here, this front is moving to the southeast. Now, they take each station that reports the weather and they plot it on the chart, and along with that station they put whole bunches of data and symbols around it to make up what is known as a station model. And what they'll do is they'll take information from each of these stations around the whole country and put them together, and it kind of gives them a distinctive picture of the weather and patterns and so on. They use the data like air pressure and wind and sky cover and temperature and dew point. And then they take all this information, they put it in a computer program, and they plot that, and that gives them the pressure patterns, the fronts, and so on. And that's how you get this big chart, and that gives us the big picture we're looking at right here. Now, let's take a look at one of these station models. Now, when we're talking about models here, we're really not talking about Tyra Banks or Christy Brinkley so much as I wish we were, but we're not. So let's take a look at what we've got. And you can see we've got a lot of information crammed into a small package here. First of all, if this station model is a circle, as you see it here, it means that a real live human being stuck his head out the window and observed the weather conditions by looking at the sky here. But if that symbol happened to be a square, it tells you the report came from an automated site. Maybe the square tells you that they think machines are still blockheads. I don't know. Some people are too, so we can pass on that. Okay, starting at that center of the circle, you'll find that the amount of sky cover is shown by how much of that circle is filled in. If it's completely filled in like this, it's overcast. 3/4 of the way filled in, be broken, and so on. So we can see we have overcast weather right here. And also you can see cloud types, things like that. We already talked about the wind. You can see the wind direction and strength. And there's all sorts of information. Here's the temperature and dew point. The temperature's 34 degrees, dew point's 32 degrees, given to you in Fahrenheit. Those kinds of things. We can see 2 asterisks here. Tells you that they're having continuous snow right now. We can see barometric pressure in millibars. It's 1014.7. We can see the rain in the last 6 hours. They've had 45/100ths of an inch of rain here. All right, so much for that little station model. Let me ask you a question. Do you think you need to memorize all of this stuff? And the answer is no, don't try and memorize all of this stuff. In fact, the METAR reports will give you all you need for the weather at a particular station. And if you want to get the most bang for your buck from the surface analysis, what you want to do is get the overall picture of the weather in your mind. And that's where the surface analysis chart really helps you out the best. So if you do want to study that station detail, what you do is take a look at the FAA's Aviation Weather Services. It's a booklet or an advisory circular put out by the FAA, and it gives you all that stuff about the station. But what you really want is the big picture in your mind. As you can see, the surface analysis chart is a great way to visualize pressure patterns and fronts and put that along with printed weather reports, and now you can get a real picture of the weather and how it's going to affect your flying. You might call this sort of a photo opportunity, if you will.